Polarity for the molecule. First of all, let's learn about the electronegativity and the polarity of the bond. Electronegativity represents the ability of the atom to pull the electron towards it. So for example, if I have hydrogen bonded to another hydrogen here we have two sharing electrons. So here, approximately the sharing will be equal. But if I have H bonded to oxygen, for example, the sharing here will not be equal. Oxygen will take the major share and hydrogen will take the minor share. And because of this situation, the result of rich electron density in this side compared to this side. And remember, the electron has a negative charge. So what's going to happen here in this side will appear a partial negative charge. Be careful, this is partial, not complete. Partial, this symbol means partial. Okay? That's how we will write it. Partial. Partial negative charge in this side, and here because it's a poor, so this is rich in electron. Here poor in electron. So what's going to happen will be partial positive charge to the side. And here, because we have two dipoles, negative and positive, that will cause the polarity. Now, how you will decide which atom has higher electronegativity or lower? Of course, we have some value, but I'm not expect you to memorize the value for all the elements in the periodic table. And instead, you will memorize the trend in the periodic table. So this is the periodic table. Going from left to right, electronegativity will increase. And going from the top to the bottom, from the bottom to the top, also electronegativity will increase. Making the fluorine here, it is the highest. Now, if I ask you, for example, oxygen here, fluorine here, oxygen here, nitrogen, carbon, which one is more electronegativity? Carbon or fluorine? Carbon here, fluorine here, electronegativity in this direction increase, so the fluorine will be higher electronegativity compared to the carbon. Now, which one is higher, fluorine or bromine? Fluorine here, Cl here, bromine here. Going from the bottom to the top, electronegativity will increase. That's make the fluorine higher than the bromine. That's how you will decide the electronegativity difference or higher or lower. Now, let's talk about the bond. If you want to decide if you have a polar bond or not, look at here. I have hydrogen bonded to hydrogen, hydrogen bonded to oxygen, hydrogen bonded to carbon. Which one is a polar, which one is not polar? If you have the difference in electronegativity, difference in electronegativity less than from 0 to 0.4 will be nonpolar. 0.5 to 1.9 will be polar. 2 and above will be ionic, not polar or nonpolar, not covalent. I'm talking here about covalent bond. If we have it 2 and above, the difference will be ionic, not covalent. Don't tell me it's a polar. Okay, guys? Now look at here. Hydrogen has 2.1, carbon 2.5, oxygen 3.5. Let's add, for example, nitrogen also 3.0. Tell me, is it a polar or not? Look at here. And we are looking for the difference, guys. Okay, it doesn't matter which one you will put it first. Here, 2.1 minus the 2.1. What the difference? It is 0. So here, none. Polar. Here, 2.1 and here 3.5. The difference will be what? Will be 1.4. 1.4. So it will be polar. So hydrogen oxygen is a polar. Carbon hydrogen 2.1, 2.5. The difference is 0.4. So it will be non-polar. Let's say I have carbon nitrogen. The difference between them is 0.5. So it will be polar. Now, look to the hydrogen oxygen and carbon nitrogen. Here we have a polar bond, here we have a polar bond. But if I ask you which one is more polarity, which bond, you will look to the difference. Here 1.4, here 0.5, both of them polar. But here the difference between hydrogen and oxygen higher than the difference between carbon and nitrogen. And that will make the hydrogen oxygen higher or more polarity compared to the carbon nitrogen. Now, let's keep going and see what we're going to have here more. You decide if you have a polar or non-polar molecule. Next, we need to assign which one has a partial negative charge, partial positive charge. We have two ends. Okay? One of them negative, the other positive. But it is partial positive, partial negative. Be careful with it. How you will decide which one has the negative end, which one has the positive end. It depends on the electronegativity. So look at here, we said hydrogen, oxygen, carbon, nitrogen. Both of them, they are polar. Now, I don't know or I don't remember the value of electronegativity, but I remember this trend in the periodic table. And what we said, going from left to right, electronegativity increase. Going from the bottom to the top, increase. Look at here. This is the hydrogen, this is the carbon, this is the oxygen here, for example. And we know they are a polar bond. But I need to assign the negative and the positive pole. Let's start with the H1. Oxygen, higher electronegativity compared to the hydrogen. Because it's a higher, so we'll have the partial negative. Hydrogen, partial positive. Carbon, nitrogen. Nitrogen, higher electronegativity compared to the carbon. Nitrogen will have partial negative, carbon partial positive. So that's how you will decide the partial negative or partial positive end. Now, one more thing. We have something it's called the vector. A vector is give you, this is a vector for dipole. For the dipole, that means two pole. The vector direction starts from the positive and towards, draw an arrow towards the negative. So here the positive, the partial positive, here the partial negative. So that's how you will draw the vector. So here, start from the positive end towards the negative. Here, positive end towards the negative end. Okay, now, to decide if you have a polar molecule or not. First of all, you will draw the Lewis structure, then you will draw the shape of the molecule. And you will check the direction of this vector. If they are cancel each other, they are in opposite direction. This is non-polar molecule. If they don't cancel each other, just in one direction, will be polar. If sometimes you have an equal pulling power, you will have also polar. Sometimes if you have symmetrical molecule, will be non-polar. Like, for example, trigonal planar molecule, symmetrical, identical atom around it, so will be non-polar. Look to this example. Carbon dioxide. This is the Lewis structure. Guys, you have to draw the Lewis structure, then the shape of the molecule is a linear. It's a linear. Now, carbon, oxygen. This is a partial positive, this is partial negative, this is partial negative. Oxygen, higher electronegativity than the carbon. Now, the direction of the dipole moment, look at here. Starting from positive end towards the negative end, starting from the positive end towards the negative end. So look at them. They are cancel each other. Cancel each other. So what's going to be? Will be non-polar. Non-polar. But look to the carbon monoxide. This is the shape of the molecule of carbon monoxide. Partial positive, partial negative, one direction, and that's it. So because of one direction, so it will be a polar. Now let's look, for example, HCN. Nitrogen partial negative, partial positive. Here hydrogen, carbon hydrogen, this is non-polar. Non-polar will not affect on polarity. Ignore it. Ignore it. So here I just have partial positive towards the negative, so it will be just in one direction, so it will be a polar molecule. So as I said, that's how you will decide the polarity of the molecule. One more thing, but not always, keep it in your mind. If there is a lone pair in a central atom, say it's a polar. But guys, not always. Most of the time, I try to make it easy for you to predict the polarity. As I said, not always. When there is a lone pair on the central atom, say a polar molecule, because the pulling power will not be the same. Look to the ammonia. Ammonia has this shape of the molecule, and guys, it's supposed to be shape of the molecule, not Lewis structure. This is the ammonia, and this the ammonium. Look at here. And hydrogen. So this is NH3. This is NH4 positive. Tetrahedral. Let's see which one is a polar, which one is not polar. Look at here. Nitrogen, partial negative. And hydrogen is a partial positive. So this is the direction of the dipole moment. And look at here. What do we have here? partial positive. We have symmetrical molecule here. The symmetrical molecule will be non-polar. So here non-polar because we have symmetrical hydrogen, all of them. But if one of them, let's say, for example, I have this one here, for example. Here, we don't have a symmetrical. So it will be here polar. So it will be polar. Let's look at the ammonia here. We don't have a symmetrical, so it's going to be polar. And other things, there is a lone pair on central atom. We can say from the beginning it is a polar. But as I said, it's not always. Be careful, guys, with the center atom it has a lone pair or not. Like for example, xenon XeF4. The xenon has two lone pair, but non-polar. Why? Because it's symmetrical molecule. So be careful.